Yeah, as promised, my brother Sean has a treat for you guys tonight. As promised, he's going to break down the origin and migration and demography of Haplogroup D. Now, the interesting thing about Haplogroup D, they have African cousins and brothers. And those cousins and brothers are known today as the Yoruba, Igbo, the Fulani, the Ashanti. We can go on and on. The list grows, right? Mainly, occupying sub-Saharan Africa and North Africa and East Africa as well, with your Amazi tribes that are E1B1B, the Horners as they call themselves, or as people reference them, they also are of the E variety, which means they are the Yap variety. So tonight, Sean is going to be discussing and breaking down the demography and origin of the Asian Yap variety. These people share a common ancestry with many African Americans and Western and Central, Northeast, South Africans. And, it's very incredible what the field of DNA will show and reveal, right? The genetic connections of people, no matter what language they speak, the geographical location, or the physical attributes. This is cutting across all of that because Japanese people in general have a certain phenotype that is not akin to what we would associate Africans with. But genetically, they share the same paternal clades. So we found that interesting and something that is pertinent to anyone that is studying ancestry. So, with no further ado, we have my brother Sean in the house. Introduce yourself, brother.
Hey, shalom, shalom, everybody. Grace and peace. Salam alaikum. What's yapping and how y'all doing? Yeah, so we're gonna go into this tonight. We're gonna talk about the populations in Southeast Africa, Southeast Asia that have haplogroup D. We're gonna talk about the migration pattern um, and the other populations that pretty much make up Japan and Southeast Asia. All right, let's see. So I guess we'll start with, hold on for a second. I'm trying to share screen. We'll start with,
You want me to open up?
yeah, go ahead. And then I'll jump in.
We al- we
Grab
also have we also have an integral part of the membership, the YAP membership here. Not only that he's a member of the YAP in the group, he's a member of the YAP biologically, and there's no other than Orthodox Moore. What's going on, brother? How you feeling?
Peace, peace, peace. What it is, fam. Shalom to the channel. Shalom to the chat. Shalom to everyone on the panel. I'm looking forward to this one because a lot of people, like we talk a lot about DE and we talk a lot about E, but a lot of people we haven't focused on D yet, and a lot of people leave that out, and don't recognize how big the Yap family actually is or whatnot. You know what I'm saying? And so I'm really, really looking forward to seeing, for a couple of reasons. Like so one, like I said, it's a big Yap family, and I think it's going to be eye opening to see how big that family actually is. But two, I'm actually interested in learning a little family history on this, right? Because like my mitochondrial is A2G, and when I was looking into the migration patterns of haplogroup A, I'm noticing the haplogroup A is over there mixing with the haplogroup D over there and whatnot. So I'm like, yeah, let me go. Let me go check this out right quick. So I'm sitting back as a fan like everyone else right now, and can't wait to learn what the OG has to bring out and whatnot.
So, Sean, you did have something on the screen. Did you want to share that?
No, not yet. Get it started. We'll go. I'll jump in after.
All right. So, the first slide we're going to present to you guys today, because we do believe in literacy here. We promote literacy to the community. So, we promote the reading of books, sources, and articles. So, the first source I want to go to is languages and genes in northwestern China and adjacent regions by none other than Dan Shu, which is a Japanese or Asian geneticist. All right, and we're going to go to his segment on the earliest settlement in East Asia, page 22 of that book. So to open this up, because when you open up and you start looking and researching the history of East Asian populations, including Japan or Japanese, you're going to run into haplogroup O, and haplogroup O has been a successful haplogroup on people to pretty much dominate, numbers wise. So if you're going to study about mainland Asia, China, Sunderland in that area, and Japan, you're going to run into this haplogroup. So we're going to read a little bit on that and then move on to haplogroup D. So the earliest settlement in East Asia, the age of haplogroup O. What does a haplogroup mean? If you've been following the YAP channel, you've been following Genesis 49ers, then you all should know the haplogroup denotes a group of individuals that share a common ancestor. Now we're dealing with paternal ancestry here. This is dealing with the Y DNA. So when you see haplogroup O, think a group of males that lived in times past. So the age of haplogroup O in East Asia is no more than 30,000 years when estimated from sufficient numbers of STR markers. Therefore, haplogroup O was not the earliest Y chromosome carried by modern human in East Asia. So a lot of the Chinese people living in the region of China, a lot of the Japanese people living in the region of Japan today are not autochthonous to this region because there were earlier settlers. And we're going to get into that. Those earlier settlers would be haplogroup CM130, may represent one of the earliest settlements in East Asia. Haplogroup C has a high to moderate frequency in Far East and Oceania, in lower frequency in Europe and the Americas, but is absent in Africa. Several geographically specific subclades of haplogroup C have been identified: C1M8, C2M38, C3M217, C4M347, C5M356, and C6P55. Haplogroup C3M217 is the most widespread subclade and reaches the highest frequencies among the populations of Mongolia and Siberia. Haplogroup C1M8 is absolutely restricted to Japanese and Ryukyans, appearing at a low frequency of about 5% or less. So again, I just want to make this clear to the audience. Like, just because you have high population density, this is a great example of that. Today, haplogroup O pretty much dominates these regions. They have a high population density. There's a lot of them there. There's a lot of the children of haplogroup O living there today and representing the populace today. But that doesn't mean that they are automatically the original people that were always there. That would be your haplogroup C markers. It says here, haplogroup C2M38 is found among certain local populations on Pacific Islands from eastern Indonesia to Polynesia, especially among the populations of Polynesia. C2 has become the model haplogroup due to severe founder effects and genetic drift. Haplogroup C4M347 is the most common haplogroup among Australian Aborigines and has not been found outside the Australian continent. Very interesting note here. A lot of people look at the Australian Aborigines and think that they're directly related. Again, going off phenotypes, they think they're directly related to like your Yoruba or your Igbos. This is not true at all. They're not directly related. The people that we are directly related to, we don't share that's in the Asian plateau, that's in the Asian areas and regions. We don't really share physical or phenotypic attributes like that on that level. So just keep that in mind. You can't use geography, can't use phenotypes. You damn sure can't use culture or language to denote someone's common ancestry. It says here, it has not been found outside of the Australian continent. Haplogroup C5M356 has been detected with low frequency in India and the neighboring regions in Pakistan and Nepal. C6P55 is geographically restricted to the highland of New Guinea. This wide distribution pattern of CM30 suggests that CM30 might rise somewhere in the mainland of Asia before the modern humans arrived in Southeast Asia. To give a clear picture about the origin and migration of haplogroup C, Sung et al. Typed 12 Y SNPs and 8 Y STRs among 465 haplogroup C individuals from 140 East and South East Asian populations. A general south to north and east to west decline of C3YSTR diversity was observed, with the highest diversity in Southeast Asia, which supports a single coastal northward expansion route of haplogroup C3 in China about 32 to 42,000 years ago using the ASD method when an average YSTR evolutionary. So just to put this in layman's terms, they see the distribution of people today that have haplogroup C, and they see it decrease the further they get away from the coast as they go north. So they believe that's showing the migration vector. That's showing the route that these people used. They came from the coast and then traveled northwards. It says here, with an average YSTR evolutionary mutation rate of 0.0069 per locus per 25 years, the arrival of haplogroup C in Southeast Asia and Australia must be much earlier than at the time, around 60,000 years ago. Therefore, a population with haplogroup C must have settled in East Asia some 10,000 years earlier than those with haplogroup O. So now we established that the other people that's in Asia. Let's move on to haplogroup D, the people that are related to Nigerians and various other Africans on the continent. It says genetic legacy of the Paleolithic period. The migration history of haplogroup DM174 is most mysterious. I give some commentary here. The reason why people say it's most mysterious because these people are related to people across the globe. So then the question comes, where is the origin? Where these people arise from? If they're related to people that's in the Middle East and it's in North, Southwest, and East Africa, how did this happen? How did they get all the way in Japan? How did they get all the way to East Asia? That's why they call it mysterious. It's like, hey, they have this marker, this YAP marker. They share this common male ancestry. So this group had to be once together. That's why you have scientists that believe it has an African origin, and some scientists believe they have an Asian origin, mainly because of the D markers, the people, the ancestors that split at some time and migrated into East Asia and later on into Japan. It says here, this haplogroup was derived from African haplogroup DE M1 YAP insertion and is associated with a short black Asian physical style. Haplogroup E and D are brother haplogroups. While haplogroup E was carried westward to Africa by tall black people, haplogroup D might have carried eastward to East Asia by the short black people. Haplogroup D M174 has high frequencies in the Andaman Negritos. So again, as you can see, haplogroup E and D are brothers. We know that because they both share the YAP genetic signature, right? They both share that on their Y chromosome. You can only get that Y chromosome from a male. So if you go back further enough in time, these people come from a male that had that signature first, and his descendants dispersed and passed it to their descendants and their progeny as they spread throughout the earth, sexually reproducing. So haplogroup DM174 has high frequencies in the Andaman Negritos. A lot of you guys should know the Andaman Negritos. They're on the island off in the Persian Gulf. They also been confused with being directly related to not like recent ancestry. They are related to Yoruba, but they also been confused with being directly related to them, like within the last 10,000 years or something. That's not true. And also, again, that's because people look at skin color and stuff like that. But they do share that relation. But again, if you walk away not knowing anything from the video, just understand that phenotype does not determine common ancestry. It says here the northern Tibeto-Burman populations and the Ainu of Japan. See, all these groups look completely different with each other, but they do share the YAP insertion. They do share common male ancestry. You go back further enough in time, they descend from the same group, the same male. It says here, and also appears at low frequencies in other East and Southeast Asian and Central Asian populations. A northern Tibeto-Burman population, the Bima D, comprises nearly 100% of haplogroup D. There are three main subclades of haplogroup D: D1M15, D2M55, and D3P99, and many unclassified minor subhaplogroups. Haplogroup D1M15 is prevalent in the Tibetans, the Tengah-Chiang, and Lolo, and also found at very low frequencies among the mainland East Asian populations. Haplogroup D2M55 is restricted to various populations of the Japanese archipelago. Haplogroup D3P99 found at high frequencies among the Tibetans and several Tibeto-Burman minorities in Sichuan and Yunnan provinces that reside in close proximity to the Tibetans, such as the Pumi and the Naxi. The paragroup D is restricted to the Andaman Islands, which has been isolated for at least 20,000 years. Some other minor haplogroups also included D ancestral can be found around Tibet. Most of the population of haplogroup D have very dark skin color, including the Andamanese, some of the Tibeto-Burman, and the Mon Khmer people. The Ainu people may have changed, here's the key, changed to pale skin to absorb more ultraviolet light in high latitude regions. So again, these people share common ancestry, but they don't all look the same. As you see, the Japanese people are usually associated with pale skin. Some of them have different eye shapes. Some of them have the epicanthic eye fold, that fatty layer over their eyes, and different phenotypic features that are not common to Tibeto-Burmans or Andamanese islanders. But they still ultimately share common male ancestry. Reading on, it says, for the origin of haplogroup D, Chandreskar et al. Suggested that the CTM168 gave rise to the YAP insertion and DM174 mutation in South Asia, based on their findings of the YAP insertion in Northeast Indian tribes in the DM174 and Andaman Islanders. So basically, layman's terms, they believe the origin of this haplogroup or these people has to be somewhere in South Asia. It says, in that case, haplogroup E with the YAP insertion might also have an Asian origin. So that's going to be your Nigerians, many of your Bantu speakers, your Almazi, a lot of your North Africans and East Africans. They also believe that they have an Asian origin as well. It says, however, this hypothesis is seldom supported by any evidence. Why does it say that? Because we still do not have ancient verifiable DNA to say, hey, this is the earliest DE settler that we see that is actually in Asia. Most of these hypotheses are derived from inferences, like the fact that you have D in Tibet, that you have D in India, that you have D in the Persian Gulf, you have D in Japan, you have D in mainland Japan, or mainland China. It says here, if haplogroup D originated in Africa, it is most mysterious how it has traveled through the populations with haplogroup CF to East Asia. Another mystery is how haplogroup D has migrated from southwest of East Asia all the way to Japan. It could have gone either through mainland East Asian or through Sunderland. The mainland route seems to be shorter than the Sunderland route. Shai et al. Proposed that the northward expansion of DM174 to Western China might predate the migrations of other major East Asian lineages at about 60,000 years ago, using ASD time estimation method with an average YSTR evolutionary mutation rate of 0.0069 per locus per 25 years. Subsequently, these frontier populations could have traveled eastward through a northern route via Korea or through a southern route via Taiwan or Ryukyu land bridge to Japan, where they might met the earlier Australian-style settlers. The current relic, DM174 in East Asia, was probably edged out of eastern China by later northern migration of haplogroup O and the Neolithic expansion of Han Chinese. So as we read earlier, C was there first, and also we see D coming in too earlier on, and then O, as they expand, they begin to push haplogroup D, the YAP carriers in Asia, out. It says here, however, there has never been any evidence from genetics of archaeology that haplogroup D2 or Negritos have migrated to eastern China. In contrast, there are still many Negrito populations in Sunderland from Malaya to Philippines. It was possible that Negritos have occupied the whole Sunderland in late Paleolithic age. Therefore, these populations might move directly from the Philippines to Taiwan to Ryukyu. The only problem was that no haplogroup D has been found in Negritos in the Philippines. Their paternal lineages might have been replaced by the expansion of haplogroup C2 and K from Papua around 18,000 years ago using batwing time estimation method. So real quick, Also, a lot of Afrocentrics, they grab these Negritos and these Malaysians, and they grab these people and say, "Hey, these are West Africans or West African related people." Actually, that's not true. Paternally, a lot of those Negrito groups that you guys see pictures of, the ones that have blonde hair, blue eyes, and dark skin, or some that look quote unquote Negroid, as you guys say, those people actually are Southeast Asian paternally and maternally. As you can see here, they have C2 and haplogroup K. Those are Southeast Asian haplogroups. Those are Southeast Asian peoples. Reading on, it says, or much recent migration of haplogroup O from the mainland East Asia. So they believe that haplogroup D was in the archipelago in Southeast Asia. They were in these places like the Philippines, so on and so forth, et cetera, Malaysia, but they will eventually be pushed out or replaced by these other Southeast Asian populations like C2K and O. It says here, however, due to the lack of data, the history of haplogroup D as a genetic legacy of a zillion age in East Asia remains mysterious. And that pretty much wraps it up on that source there. So, Sean, did you want to follow up on that? Are you there, Sean? All right, so I'll share some more
No,
information.
I'm here. I'm here. I'm sorry, fam. I was trying to do something real quick. But yeah, real quick. You want to share something else? Because I'm going to jump into the phenotype real quick so everybody understands what these people look like. From the Jomon or the Ainu to the Yayoi. But if you want to, finish off something real quick, or you're good.
No, you got it. Go ahead.
All right, let me share screen. Hold on, where was I? Okay. All right. So these populations, family. So can y'all see the image? Can y'all see? Am I sharing screen?
Yeah, it's clear. I see it.
All right. So to your far left, you would have this would be a haplogroup D, hunter-gatherer, your Joman or your Ainu. Then you have the Yayoi, which would have came in through the Korean Peninsula, haplogroup O. And when they mixed, they would have. This is what you would. This last one on the far right. You see, he has a little bit of hair. It's not as full as haplogroup D or the Joman, and you see the Ainu just has a small mustache. So you can see the phenotypic variation as these people came in. So we have another picture here, real quick. I'm just trying to give y'all a quick overview of what. Sorry, a quick overview of what they would have looked like. These hunter-gatherer Asians, East Asians, and these rice growers, these wet rice growers, and wet rice farmers, and the Yayoi people in Korea, coming off the Korean Peninsula, off of the continent of Asia. All right, so from there, I'm going to go here. You can see that?
Yep.
Am I sharing? All right, so this is Y chromosome evidence of the earliest modern human settlement in East
Oh,
Asia.
no. We see the image. We still see the image.
Oh, okay, hold on. Stand
So
by.
there should be a tab above there that says share this tab instead. Do you see that on your
Hold
browser?
on. Yeah, I got you. Hold on. Where is it?
Right below the tool address.
You see it?
There you go.
Okay. So this is Y chromosome evidence of the earliest modern human settlement in East Asia and multiple origins of Tibetan and Japanese populations. So as my brother went over real quick, so I'm gonna just bolster what he just read off, the origins, the Y chromosome. So introduction, the Y chromosome allele YAP, also called M1, defines the deep-rooted haplogroup DE of the global Y chromosome phylogeny. This DE haplogroup is further branched into three subgroups, DE, D, and E. The distribution of DE haplogroup is highly regional, and the three subgroups are geographically restricted to certain areas, therefore informative in tracing human prehistory. The subhaplogroup DE, uh, presumably the most ancient lineage of DE haplogroup, was only found in Africa from Nigeria, supporting the out of Africa hypothesis about modern human origin. This, the subhaplogroup EM40, defined by M40 SRY and M96, was also suggested originated in Africa and later dispersed into the Middle East, Europe, and Europe about 20,000 years ago. Interestingly, the subhaplogroup D defined by M174, DM174, is East Asian specific, abundant appearance in the with an abundant appearance in the Tibetan Japanese, 30 to 40%, but rare in most of the East Asian populations and populations from regions bordering East Asia, Central Asia, North Asia, and the Middle East, usually less than 5%. Under DM174, Japanese belongs to the separate sublineage defined by several mutations, M55, M57, M64, which is different from those in Tibetans, implicated relatively deep divergence between them. The fragmented distribution of DM174 in East Asia seems not consistent with the pattern of other East Asian specific lineages, which which would be O3M122, O1M19, and O2M95 under haplogroup O. All right, so we have a tree here. You see C is over here, breaking off a CT. You have DE coming down here. So we have M40 up here, M96. And then we have all the Ds, D, D1, D2, D3. All right, let's run through this a little bit because we want to get into the other populations. Besides besides Tibetans and Japanese, DM174 is also prevalent in several southern ethnic populations in East Asia, including the Tibeto-Burman speaking population from Yunnan province of southwest China, about 14.0 to 72.3%. One Hmong Mine population from Jinsu of southern China, 30%, and one Dayak population from Thailand, 10%, which could be explained by fairly recent population admixture. However, a recent study reported a high frequency of DM174 in the Andamanese. I don't know if we're going to get to touch on the Andamanese tonight. We're going to probably stick with the Yayoi and the Jomon or the Ainu people. We'll probably touch on the Andamanese on another video. In Andamanese, 56.25%. People who live in the remote islands in the Indian Ocean and considered one of the earliest modern human settlers of African origin in Southeast Asia. Another study by Underhill et al. Suggests that the DM174 lineage likely reached East Asia about 50,000 years ago. This implies that Yap lineage in East Asia could be indeed very ancient. Our previous studies showed that the dominant and East Asian specific Y chromosome OM175, 44.3% on average, reflect possibly the earliest modern human expansion in East Asia. Unlike the prevalence of OM175 in most of the East Asian populations with relative high frequency of DM174 are mostly located at the peripheral regions of mainland East Asia with fragmented distribution, implying two possible explanations of human prehistory. Firstly, like OM175, DM174 may also be just one of the lineages going northward toward during the suggested Paleolithic migration of modern humans in East Asia. Subsequently, due to population substructure, the last glacial is likely a key factor, and recent expansion of Han culture, the distribution of DM-174 was fragmented into the current geographic pattern. The other possible scenario would suggest an independent earlier migration different from the one we proposed previously. To address this question, we conducted a systematic sampling and genetic analysis of more than 5,000 male individuals from 73 East Asian and Southeast Asian populations based on Y chromosome SNPs, SNPs, and STRs. Data and the estimated ages of the major DM-174 lineages, we proposed that there was an independent Paleolithic northward migration of modern humans in East Asia predating previous suggested Northwest populations movement. All right, so uh, we'll go to the results real quick. Uh, Table 1 lists the reported YAP plus frequencies in worldwide populations referred to the table noted references. Africans have the highest frequency of YAP plus, and all of them belong to the subhaplogroup EM40. In contrast, DM174 is generally East Asian specific and with sporadic occurrences in adjacent regions, Central Asia, Middle East, and Northeast India. The average frequency of DM174 in East Asia is 9.60%, with high frequencies in Tibet, 41.31% in Japan, 35.8% in Andaman Islanders, 56.25%, but rare in other East Asian populations, uh, less than 5%. After genotyping the Y chromosome biallelic markers M174, M40, M15, M57, and P47, the 719 YAP plus samples were assigned to six sub-haplogroups: E, EM40, DM174, D1, M15, D2, M57, and D3, P47. Further typing for 8 STR loci of the 719 YAP plus generated the complete STR data sets for 697 samples, as shown in Table 2, consistent with the previous reports. The prevalence of DM174 is mostly in Western and Southern China and Japan. So basically, this is the breakdown of the sample sizes. Actually, I want to go where I want to go next.
I think the discussion will be a good way to wrap
To close
everything
this
up.
one out. All right.
Yeah, the discussion and the conclusion. Yeah, but great
Hold
points.
on, hold on. Yeah.
Your screen is gone, Sean. Sean, are you there? All right, to recapitulate until we get our brother Sean back, he brought again more information about the children of Haplogroup D, the ancestors of your Ainu people. Showed other haplogroups that are involved in the regions. As I pointed out earlier, that a lot of these haplogroups overrepresent these regions, and the haplogroup D has been reduced in numbers. Are you there, brother?
Yep, I'm here.
All
You
right,
hear
go
me?
ahead, brother. Yeah.
All right. So we got the results. Table 1 lists
You
the
read that.
report why. No,
You read
I
that
did.
portion
Oh,
already.
sorry. Went to discussion. I said conclusion. Hold on. Oh, cool. Why am I getting this problem here? Sorry about that.
The discussion's above right there.
Yeah. Okay. The bias distribution of DM174 bears the different possible inferences of the human population prehistory in view of the origin and migratory pattern in East Asia. The hypothesis of the northern of northern origin of DM174 is not supported by not supported by our data because DM174 is rare in Central Asian populations. And the few Central Asian DM174s are all located at the peripheral position of the YSTR network. Our data also disproves the notion of Indian origin, since no DM174 was detected in the 966 individuals across India. The sample size 966. The sporadic occurrence of DM174 in northeastern India, two DM174S in 232 individuals tested, is because those populations are in fact Sino-Tibetan speaking populations. The lack of gene flow between Tibet and India is likely due to the efficient geographic separation by the Himalayas. Uh, on the other hand, the Aborigines living in in the Andaman Islands are genetically isolated in view of their Y chromosome haplotypes. Though phenotypically different from other Southeast Asian populations, the Andaman Islanders possess most of their major East Asian specific Y chromosome lineages, including DM174, O3M122, and O2M95, a strong indication of a relic Paleolithic population. Also, the Dayak and Hmong speaking populations are ancient southern populations in view of linguistic and archaeological evidences. The network a- analyzes uh, analysis indicates the clear divergence of D1M15 between northern Tibetan Burman and southern Dayak Hmong populations. Hence, origin the alternative explanation of northern origin of DM174 is unlikely considered the absence of YAP plus in northern Asia. And the sporadic appearance of DM174 in Central Asia, consequently, the southern origin of DM174 can be established, which is consistent with the proposed initial settlement of modern humans in mainland Southeast Asia and the migration pattern of other Y chromosome lineages. There were studies arguing against the southern origin of East Asian, in which higher gene diversity was observed in northern populations compared with southern populations. As we discussed in our previous report, the data from Karafat et al. 14 suggests a false impression of high diversity of northern populations without taking the recent admixture from Central Asia into consideration. The study of Zhu et al. I guess that's slide 30, has the similar drawback through both YSMP and YSTR data were used. In Zhu et al. 2006, the high gene diversity was claimed for Mongolian, Uyghur, and Manchurian, and all of them have recorded recent extensive admixture with Central Asian and Han Chinese populations. In addition, the southern population studied in Zhu et al. 2006 were limited, the and the within population bottleneck effect caused by long-time geographic isolation might have a great impact on gene diversity estimation. When, when plenty southern populations were studied, we observed a higher diversity in those populations compared with northern populations. The gene diversity based on STR data in the southern population is compared with those in northern populations. Tibetan has the highest diversity, 0.525 plus or minus 0.294, followed by Dayak, 0.484 plus or minus 0.272, Japanese, 0.419 plus or minus 0.239, and the Hmong, 0.347 plus or minus 0.206. Gene diversity of other East Asian populations was not calculated due to the small sample size. The higher diversity in Tibetan is largely due to the excuse me, due to the much larger effective population size of DM174 in Tibetan compared with other populations. Tibetan and Japanese lived in two geographical far away regions, and their DM174 lineages belong to two different subhaplogroups. These two subhaplogroups all have a short distance and star-like network structure, which indicates a long-term local existence and recent population expansion. It should be noted that the estimation of gene diversity is subject to potential bias. The age difference of DM174 sublineages, the findings of 2DE in Tibet, which was only observed in Africa, supports the antiquity of DM174 and suggests that DM174 lineage is among the earliest modern human settlers in East Asia. Additionally, the base distribution of the bias distribution of uh, the bias distribution of DM174 and its ancient coalescence time suggests an independent Paleolithic migration of modern humans in East Asia. Our previous data on the O3M122 lineage suggests a prehistorically northward migration about 25,000 to 30,000 years ago of modern humans in East Asia, which explains the current phylogeography of the major East Asian specific Y chromosome lineages O3M122, O2M95, and O1M19, O1M119. However, the data in DM174 cannot be explained by the hypothesis migration pattern. Firstly, DM174 is rare in the central part of Eastern Asia, especially in Han Chinese populations. Though this could be explained by genetic drift, assuming DM174 moving along with O3M122 during the proposed northward migration, the prevalence of DM174 in Tibet and Japan requires current mutations of independent random enrichment of DM174, which is unlikely. An independent earlier northward migration is more reasonable in explaining the current distribution of DM174 in East Asia. We speculate that due to the later northward migration of O3M122 and a Neolithic expansion of Han Chinese, the trace of the DM174 migration in the heartland of East Asia was wiped out by the later and likely much larger migration of O3M122. So this is an earlier paper. So um, the next paper I read is going to basically say that they don't find that one was wiped out, that they pretty much uh, lived amongst each other and procreated amongst each other, and they pretty much stayed together. There was no war or anything going on between these two populations. The current peripheral wide out the current peripheral distribution pattern of DM174 in East Asia is consistent with the proposed notion. Also, the age estimation supports that the northward migration of DM174 may predate the migration of of O3M122. The East African mega droughts about 135 to 75,000 years ago, during the early late Pleistocene, was suggested compelling modern humans out of Africa, and the early modern human could occupy coastal areas and exploit the nearshore marine food resources by that time. Then the modern humans was suggested expanding along the tropical coast. Excuse me. In the earliest modern human fossil found of Africa was about 100,000 years ago. The period of 80,000 to 10,000 years ago during the last glacial might have a huge impact on modern human migration, and the sea level had fallen 50 to 200 meters below present, which resulted in a larger dry lands and possibly for human migration between currently separated lands by ocean between Japan and the mainland. Human fossils human fossils record human fossils records the previous genetic data suggests that the earliest human settlement in East Asia likely occurred less than 60,000 years ago. For example, the oldest Australian fossil, Lake Mungo uh, 3, was dated about 45,000 plus or minus 3,000 to plus or minus 3,000 minus 62,000 plus or minus 6,000 years ago. And the mitochondrial DNA and Y chromosome analysis of current Australian ethnic population suggests the colonization of Australia about 50,000 to 70,000 years ago. Our age estimate of the DM174 lineage is consistent with this notion, though there might be independent migration of modern humans into East Asian and into Australia. The estimated ages of the DM174 lineages are older than those previously reported based on Y chromosome and mtDNA variation in East Asia. To see whether it is overestimated using the same method, we calculated the divergence time between DE and EM40. The estimated age is 27,176 years, which is much younger than the DM174 lineage, but consistent with the previous estimation, 27,800 to 37,000 years ago. Hence, the antiquity of DM174 likely reflects the true prehistory of human populations in East Asia. The age estimation model developed by Zavoski is not sensitive to effective population size and recent population expansion, though the effect of population substructure cannot be totally ruled out. The antiquity of DM174 was also supported by a previous study in which the origin of DM174 was estimated more than 50,000 years ago. The divergence time of Haplogroup D is about 60,000 years ago. Considering the wide, though fragmented geographic distribution of DM174, the proposed Paleolithic migration would be the first northward population movement of modern humans after their initial settlement in Southeast Asia. As the last glacial occurred during 80,000 to 10,000 years ago, the northward migration of DM174 is consistent with the proposed notion that modern humans might exploit the food of mammoth steppe, besides the later population expansion. The cold weather during that the cold weather during the last glacial may also contribute to the current fragmented distribution of DM174. Interestingly, a recent archaeological finding support the modern humans explored the Tibetan Plateau about 30,000 to 40,000 years ago, which is much earlier than previously suggested, but consistent with our hypothesis. The afterglacial sea level rise eventually led to the separation between Japan and the main continent, which explains the relic distribution of DM174 in current Japanese populations. The archaeological data suggests that the initial colonization of modern humans in Japan occurred about 30,000 years ago, consistent with our age estimate of D2M57, 37,678 plus or minus 2,216 years ago. Taken together, the current Tibetan Japanese population are probably the admixture of two ancient populations represented by DM174 and O3M122 respectively. All right, so what I want to jump into now is, so basically this was just given the migration pattern, the last glacial maximum, which route they would have took, how long it would have took them, um, things of that nature. So let me go back here. Y'all still hear me? Your should be still there? More y'all still there? Make sure y'all still hear me.
Yeah, you good.
All right. All right. So what I want to touch on now is the two populations, haplogroup Y and haplogroup O, which is the Yayoi, and haplogroup D, which is the Jomon or the Ainu. So I think the best place for me to go now is, all right, so let's go here real quick. The origins of Japanese people in Japan. All right, and this is off of Wikipedia. So genetic evidence. It is now believed that the modern Japanese descend mostly from the interbreeding of the Jomon era peoples, 15,000 to 500 BCE, composed of the above Ice Age settlers and a later arrival from China. Can y'all see this?
Nah, it's not sharing, OG.
All right, stand by.
I don't even see it.
Yeah, stand by. I got you.
I'm in the back, like, so that's all.
Origin Japan. Where is it? Okay, there it is. You can see it now?
It's coming up. Yeah, and FYI, when you're sharing screen, if you want to, like, you can just like do like the share all or whatnot, to where like it's just to where you can just go from screen to screen and it shares every time.
Okay, so the view tab screen, the view tab button.
Instead of yeah, you can.
Right.
Yeah. So when you're
All right, cool. All right, so we're going into the introduction on this, the origins of the Japanese people. All right, so this is going to touch on both populations, the Yayoi and the Jomon or the Ainu. Just going to give you a little something from here. The origins of the Japanese people is not entirely clear, yet it is common for Japanese people to think that Japan is not part of Asia, since it is an island. So it's an archipelago, cut off from the continent. This tells us a lot about how they see themselves in relation to their neighbors. But in spite of what the Japanese may think of, instead of what they may think of themselves, they do not have extraterrestrial origins and are indeed related to several peoples in Asia. Actually, let me jump down here. All right. It is now believed that the modern Japanese descend mostly from interbreeding of the Jomon era people, 15,000 to 500 BCE, composed of the above Ice Age settlers, and a later arrival from the China and/or Korea around 500 BCE. The Yayoi people crossed the sea from Korea to Kyushu, bringing with them a brand new culture based on wet rice cultivation and horses. As we will see below, DNA tests have confirmed the likelihood of this hypothesis. About 54% of paternal lineages and 66% of the maternal lineages have been identified as being of Sino-Korean origin. Evidence has emerged from ancient DNA testing that there may have been two major waves of migration from the continent of Japan. The Iron Age Yayoi invasion from Korea was only the most recent of them. Kenichi Shindu 2003 found Chinese-looking maternal lineages, haplogroup A, B, F, MAA, and M10 in Kanto region dating from the late Jomon period, mixed with the typical Jomon lineages, M7A and N9B. These are the maternal lines. More A is here, B is here. We get ready to go into that later on, dealing with the maternal haplogroups going into the Americas from East Asia. although this hasn't been completely confirmed yet, this could indicate that farmers from mainland China colonized Japan several millennia before the Yayoi invasion, which would explain why the Japanese also possess typical South Chinese Y chromosomes not found in Korea, such as O1A, O2A, O3A, 1C, SNP JTS002611, and O3A2, P201. Let's see. So we're going to start with the Y chromosome, as you see. So the Y chromosome frequency of selected East Asian populations. All right. So the Japanese, you have the C 3.25, C2A, C1A1, C1A1 3.5, and the Japanese C2A 3.5%, D1A is basically negligible, but D1B 39%, N2% 1.5% on the O, O1A, O2, O2A, 1 and 1.5%, O2B 29%, O3 19%, Q negligible 0.1%, and others 0.5. But if you go down to the Ainus, you see that they're mostly D1B, 85%. If we go further down to the Ryukins, they're 45.5% D1B. You go down to the Koreans, so you have a D1B pretty much touching all of these populations, except for the Mongols and the Manchus. Everyone else has a little touch outside of the Southern Han and the Taiwanese Aboriginals. But you see they're high, like the Taiwan Aboriginals, Haplogroup O1A, 84%. What else we got here that's pretty high? 15%. But you see it touches basically all of the Eastern, South, Far East populations, all right, except for the Ainu. But once, as you see it, the Ainu is, no Q, no O's. So let's go down. So we have another graph here, C1A. So I want to try to make this larger. Let's see if I can make this larger. Y'all can see that?
Yep, you good.
All right, cool. So this is the Japanese archipelago. All right, from North Japan all the way down to West Japan, all the way up to the Ainu Islands. So Ainu would have came in right across the same way. They hypothesized that they would have came in the same way the Yayoi would have came in, which was off of the Korean Peninsula. All right, and as you see, you have D1A, which is in the green, D1B, which is also in the green. You have C1A, which is this little slither right here. And you have a lot of O. All right, so these people were mixing up together a lot, except for when you get the Ainus that was pushed all the way north into the Ainus Island. As you see, they're mostly D1A, and that's C2A, with the color graph. Let me back out of this now. All right, so this is going to give you a breakdown of the different Y chromosomes that's there. Haplogroup C1A seems to have a split around 45,000 years ago in the Middle East of Eurasia. One group going west to Europe and the other east to Japan. C1A2 was found among the first Paleolithic Europeans, Cro-Magnons, during the Ariganese period, and was still relatively common 7,000 years ago, both among Mesolithic West Europeans and Neolithic farmers in Anatolia. C1A2 is now nearly extinct in Europe. C1A1 is particularly common in Okinawa, 7%, Shikaru, 10%, and Tohoku, 10%. But is apparently absent from Hokkaido, and Kyushu. Okay, haplogroup C2A, representing also 3% of the population, is typically found among the Mongols, Manchus, Koreans, and Siberians, which suggests a a propagation by the Yayoi farmers. The last surviving tribes of the pure Ainu people living in the islands of Sakhalin and Russia, just north of Hokkaido, 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 possesses 15% of C2A, the remaining 85% being D1B. There is therefore a good chance that C2A could also have come to Japan from Siberia to Sakhalin and Hokkaido. C2A is indeed found in both extremities of the country, peaking in Kyushu 8%, Hokkaido 5%, but is rare in central Japan, supported, which supports the theory of the two separate points of entry. Over 40% of Japanese men belong to Haplogroup D, a paternal lineage thought to have originated in East Africa from 50,000 to 60,000 years ago. Its first carriers would have migrated along the coast of India, along the coast of the Indian Ocean from the Arabian Peninsula all the way to Indonesia, then following a chain of islands up through the Philippines and using the land bridge from Taiwan through present-day Ryukyu islands to Japan. Korea and Sakhalin would have been connected to Japan during the Ice Age, allowing D tribes to continue their migration to eastern Siberia, Mongolia, northwest China, and ultimately ending up in Tibet. Nowadays, Haplogroup D only survives scattered in very specific regions of Asia, the Andaman Islands between India and the Myanmar, uh, Indonesia, only a small minority, southwest China, Mongolia, also small minority of Tibet. Also, we have haplogroup D1B, aka DM55 or DM64.1, formerly known as D2, is 23,000 years old and would have arrived in Japan around the time of the last glacial maximum, 24,500 to 17,500 years before present. When a land bridge connected northern Japan to Siberia, D1B is found almost exclusively in Japan, with a small minority in places who have had historical ties with Japan, such as Korea. D1B is most common in Hokkaido, 60 to 65%, followed by Tohoku and, and Kanto, 40 to 50%, and its frequency declines as one moves towards Western Japan, 25 to 30% in Kyushu, Chugoku, and Shikoku, which have higher percentages of Y haplogroup O. Okinawans also have high levels of D1B, 45%. If D1B colonized Japan from the north, it would explain why its frequency is highest in northern Japan, and conversely also why pre-LMG lineages, last glacial maximum, lineages like C1A1 survived better in southern Japan, notably Okinawa and Shikoku, excuse me. All right, so we'll go down to haplogroup O. Almost exactly half of Japanese men belong to haplogroup O. This would basically be your Yayoi people, a paternal lineage of Paleolithic Sino-Korean origin that is now found all over East and Southeast Asia. Haplogroup O2B, aka OSRY 465, is found especially in Manchuria, Korea, and Japan, and very probably uh, and very probably came to Japan with the Yayoi people. It reaches its highest frequency in Western Japan, 35%, and is least common in Hoiidu and Koidu, excuse me. Getting tongue tied here. Let me take a sip of water. Hold on for a second. Yeah. All right. And it's least common in Hokkaido, 12.5%, and Okinawa, 22%. In the rest of the country, its frequency is around 30%, approximately two-thirds of the Japanese O2B belong to the O2B1 subclade, which is much less common in Korea and Manchuria, possibly due to founder effect among the Yayoi invaders. We have also haplogroup O3, aka OM122, is the main Han Chinese paternal lineage. It is an extremely diverse lineage. The numerous subclades include many associations with expansion of agriculture from North China. Most of them are found in Korea and would have been part of the Yayoi migration to Japan. However, some specific subclades, notably O3A1C JST002611 and O3A2 P201, are considerably more common in southern China and among non-Aboriginal Taiwanese, 25%, than in Korea, 6%. Within Japan, it reaches a maximum frequency in Okinawa, 16%, a region with low Yayoi ancestry. Let's move down. I want to get to the mitochondrial. So if we look at the mitochondrial DNA, we have some Aboriginal American haplogroups. We have A, and you see that in the Koreans, they're about 8%. Japan, they're about 7%, 8%. And Ryukyns, the Ainus is 4%, and the Taiwan Aborigines is 0%. B4, which is where B2 breaks off from, B2B breaks off from, 5% Koreans, Japanese, 7.5%, 11.5% Ryukyns, and the Ainu 2%, 17%, and Taiwan Aborigines. If we move further down, we'll see that maternal D4 and D5 have a large presence in the area. Move down, we'll see that the M's pretty much have the lion's share on the maternal side in the region. All right, let's get out of here. It's getting late. Let me try to move this along. So, sorry about that. I want to change screens. So I want to go.
Yeah. Sean giving you guys the history of Ivory and his people, because Ivory is DM55. I'm unveiling it right now. He ain't showing his haplogroup, but Ivory is DM55. He is ancestrally a Japanese, Jomon, right? And it's Sean. I already told him that he from Ching-a-ling-a-ling, fried dumpling tribe and damn self. So he giving you guys the history of their people. You understand? They give you the ancestry. Go ahead, Sean.
All right, we're gonna jump into the Yayoi culture real quick. This is from Botanica. Y'all can look into this, when you get a chance. The Yayoi culture. So the Yayoi would have came in around 300 BCE or 250 BCE. They would have came in off the Korean Peninsula into the archipelago, the Japanese archipelago. And so we're going to read a little bit of their history or their culture, prehistory culture of Japan, subsequent to the Jomon culture, named after the district in Tokyo, where its artifacts were first found in 1884. The culture arose on the southern Japanese island of Kyushu and spread northward toward the Kanto Plain. The Yayoi people mastered bronze and iron. They wove hemp and lived in village communities, thatch roofed and iron casting. They wove, oh, excuse me, I went back to this other. They wove hemp and lived in village communities of thatch roofed, raised floor houses. Slow down, excuse me, I'm getting sleepy. Raised floor houses. They employed the method of wet paddy rice cultivation of Chinese origin and continued the hunting and shell gathering economy of the Jomon culture. Yayoi pottery, like earlier Jomon ware, was unglazed. Pottery of the early Yayoi period, 300 to 100 BC, was characterized by knife incised surface decorations. During the Middle Yayoi period, 100 BC to 100 CE, pottery objects with comb mark decorations appeared. Forms forms of this were sorry, excuse me, I'm really getting sleepy. Give me a second. Let me get it together. Let's start over. Yayoi pottery, like earlier Jomon was unglazed. Pottery of the early Yayoi period, 300 to 100 BCE, was characterized by knife-incised surface decoration. During the Middle Yayoi period, 100 BCE to 100 CE, pottery objects with comb mark decorations appeared. Forms of this warm, russet colored ware included tall-footed vessels, large and small jars, bowls, and spouted vessels. Yayoi ware appears well thrown, but was made by the coiling method. That is, by preparing the clay in the shape of a rope and coiling it spirally upward. Surfaces were smoothed with a paddle or edging tool, then painted in red and polished to a high finish. Pieces produced in the last stage of the period were often undecorated. Yayoi sites have yield bronze mirrors and coins bearing similarities to Chinese Han Dynasty bronzes, ceremonial bronze weapons, swords, spears, and halberds, and bronze bells, decorated with incised geometric designs and stick drawings. All right, so that's the Yayoi culture. I want to type in right quick. Jomon. Jomon culture. Jomon culture. Jomon culture, earliest major culture of prehistoric Japan, characterized by pottery decorated with corded pattern, Jomon. Impressions of reliefs. For most time, for some time, there has been uncertainty about assigning dates to the Jomon period, particularly to its onset. The earliest date given is about 10,500 BCE, which is described by scholars favoring it as the beginning of the incipient Jomon period that lasted until approximately 8,000 BCE. Others prefer a late start date, which may range between 7,500 and 4,500 BCE, depending on the interpretation of archaeological evidence. Most generally, most generally agree that the period ended about 300 BCE with 100. I'm sorry, why did it end? I apologize for that, family. All right, let me go back. You know what? Get back here.
What you need, Sean?
Nah, it disappeared on me. I'm gonna go to something else. I'm sorry. All right. So Japanese population, Japanese considered from the hypothesis of farmers and language.
Why you get that? Kedrick said that explains why they can fry a mean chicken. you
Makes
know,
sense.
the viewing audience, African Americans are very what's the word for it? They're very open to Asian, and they're very fond of Asian culture. A lot of us we may have grew up watching. I know your age group and other age groups as well grew up watching martial art films and Bruce Lee and a lot of the kids today they're into anime and manga. That's all Japanese derived, and a lot of inner urban or inner city kids they grew up eating orange chicken, stuff of that nature. So, a lot of people are fascinated, especially African Americans, are fascinated with Asian culture, cuisine, and stuff of that nature, man. So, um, I think it does touch, a certain demographic a different way. Explaining that hey, you actually do share cousins and brothers and stuff of that nature, in Japan and in East Asia, in general, you do have some distant relatives there. So, whenever you're ready, brother. You've done a great job. You presented a couple papers already, man. I'm hoping you guys are learning something. Y'all getting something from this lesson here. Shauna's doing a fantastic job at breaking down pretty much each migratory step, where these people were, how they got there, the origins, the northward migration, et cetera, et cetera, et cetera. The other groups that there were also in mainland China and Japan. He brought up the land bridge thing. In a glacial period, water levels tend to drop because most of the water that's normally in the sea would be frozen. They'll be encapsulated in glaciers. So the sea level will drop, and a lot of land bridges that are connect to a lot of these archipelago and these islands like Japan, they're there so people could just walk instead of having to use maritime like ships or something to sail there. They could just walk to these places, and as the ice glaciers melt, then the sea level rises again and covers those regions that were once dry land with the sea. So, and then you get people that are semi-isolated on these islands or archipelago regions like the Philippines, so on and so forth, et cetera, et cetera. All right, Sean, you got it?
Yeah, I'm back. Hold on. Let me grab it real quick. Where is it?
Yeah, ultimately, if you go back far enough in time, all humans are going to coalesce to one group anyway. We're all humans at the end of the day, modern humans. So we all share common ancestry. But humans branched off and developed their own sects of humans. And the sect of humans that, I belong to, Sean belong to, and more belongs to, we all share the YAP signature on our Y chromosome. So we all know that we're related within the last 70,000 years, which includes these Japanese people and these East Asians that he's bringing up tonight. Go ahead, brother.
All right. Y'all can hear me?
Yep.
All right. So the origin of the Yayoi people. All right. So Martin Fackler of the Association Press wrote, analysis of the skull shapes has shown the rice farmers who appeared 24,000 years ago were racially quite different from the hunters who they replaced, which would be the Jomon or the Ainu. In the 1980s, new research on DNA taken from burial remains revealed even more startling results. The island's first inhabitants had little in common with most modern Japanese, but were almost identical to the Ainu, a tiny indigenous group now found in Hokkaido. The same analysis also showed modern Japanese are close genetic kin to Koreans and Chinese. Debate amongst the researchers focused on just how many migrants came, whether they violently displaced the natives or peacefully intermarried with them. All right. Actually, I want to just go to the genetic data. All right. So this is the Yayoi. The haplogroup O expansion, a second migration wave arrived in Japan about 2,000 to 4,000 years ago and was composed of Yayoi people who brought the cultivation as well as weaving and metalworking from Korea and the uh, northeastern Asia. At this date, the land bridge to Japan, to the Japanese islands were submerged, and seafaring migration must have been responsible for the spread of the Yayoi. Japanese are also carriers of haplogroup O. Subclade O3 is a major branch represented in East Asia, which is connected to the agricultural revolution and Neolithic era. The Yayoi origins are estimated to have contributed approximately 52% of the current population, while the Jomon contribution estimated at 40%. So you see, this is, I don't know, it's kind of small probably on you guys' screen, but you can see how the Yayoi came in off of the Yayoi Peninsula into the archipelago. And once they came in, you see you had Jomon moving to the south and you had them moving to the north. And the Yayoi was pretty much basically in the middle. Eventually, a lot of the Jomon got pushed north. Um, those with pure, what they would call pure Yayoi or Ainu pedigree. Okay, I gotta put this down because it's getting late. There's something else I wanted to touch. Uh, take over for a second, bro. I want to find this other piece, and this is going to be my last part.
All right, yeah. So very intriguing stuff. Very intriguing stuff about the Jomon and their relation to haplogroup D and the Yayoi coming in and disseminating haplogroup O. So again, same thing with Asian groups, with any group, just because they may share the same phenotypic variation or same look, physical morphology, same nose shapes, face shapes, eyes, eye color, hair texture, does not mean they necessarily are directly related or recently related. As you can see, you have two separate groups here, two separate cultures, and two people propagating these cultures that are living on the island of ancient Japan, or Jomon, or whatever you want to call the ancestral abode known as Japan today. And they have different migration vectors. As you can see, the haplogroup D or YAP carriers are more to the north and south. So it's very important. And I always like to, in these videos, these type of videos when dealing ancestry, because in the West, in America, a lot of people will look at skin color, the way you look, your hair texture, and try to use that as a DNA test to say, hey, we must all be connected because we all have a similar look. That's not true. Again, we can use the Japanese population as a case study because the Japanese population don't all share the same male ancestors. No, neither do they all share the same female ancestors. They don't. So, as he read earlier, haplogroup D is about 30 to 40% of the Japanese populace, right? So that lets you know these people are more closely related recently, within the last 70,000 years to your Nigerians, to your North Africans, your Amazigh, et cetera, than they would be the haplogroup O carriers, right? Which will have came later into Asia after D and after haplogroup C. So that's just how ancestry works. You don't have to look like the person to be related to the person. You don't have to speak the same language as that person to be related to them. And you damn sure don't have to share the same geographical proximity. As you can see, that's why the geneticists, they were confused when they first did the DNA analysis of Japanese people and several other Asian groups, and like, wait a minute, they got this YAP marker. How they got the YAP marker, and these Africans have the YAP marker as well, and these people in the Middle East have the YAP marker. They're separated by thousands and thousands of miles. They're diametrically opposed to each other, and that just shows you the unique history of humans. We're known to migrate. We're known to move around. We're not known to be static. We move around. We travel for thousands of miles. We reproduce, and the successful lineages grow big, and the unsuccessful lineages just maintain, or some just fade to the back. And that's what we see throughout human history. Tonight we're dealing with haplogroup D, but that's true for most haplogroups, right? So again, you can't judge an ancestry based off culture, skin color, someone's hair texture, or something of that nature. It just does not work that way. As we read earlier, the Negritos, they have Negroid features, they have Negroid hair texture, but they themselves are Southeast Asian in origin. They don't have anything to do with, let's say, someone from the Isan tribe, right? Or someone from the Fulani. So same thing, same principle here lies with the Japanese population. 30 to 40% of these people are Yap descendants. Even though they may speak the same language as their haplogroup O counterparts, they may look the same or look similar and share the same culture. It does not necessitate common ancestry.
No, that's facts. That's just like a lot of people in America speak English or whatnot, right? However, the majority of African Americans don't carry the haplogroups of the people who invented the English language or whatnot, right? So they can, like you're saying, they can speak all kind of different languages or whatnot, but that does not leave a genetic imprint, right? Their genetics is what their genetics is or whatnot. So some people even say that the Negritos or Adamese Islanders, etc., they liken them to pygmies or whatnot, right? But we can see that they have a completely different haplogroup to the pygmies in Africa and whatnot. So they may look similar, but they're from a whole different paternal lineage.
Facts. Hey, Sean, you got what you needed? You're on mute,
Yeah, I'm
bro.
ready to go. Yeah, I got it. I'm ready to go. All right. So there's one more population that they're finding in the Japanese genome. Sorry, hold on. It froze on me. Damn it. 1 second. Why did it freeze on me?
It froze up on you?
Yeah, hold on for a second.
All right, so while he gets that, I'll show this real quick, Sean, while you're working on that, or you can stop me when you want. What's interesting also about haplogroup D in a paper that was written in 2019. That was a paper that was released in 2019, and it was discussing some of the matches with haplogroup D. And what's interesting about this is that they found not only the matches in Nigeria, because the first thing people go to is the Nigerian matches, which is also amazing as well, but they found Saudi Arabian and Syrian matches.
Yes.
With the DO. Yeah.
Yemen, all that. Yeah.
Mm-hmm. Which is showing the distribution. Just looking at this tree, you're seeing the distribution. As he read earlier, D1A, D1B, mainly in Japan, and we see it in East Asia. But we see it in Saudi Arabia and Syria as well, and in Nigeria, showing the distribution of YAP is very wide, right? You can see it's in West Africa, it's in Saudi Arabia, it's in Syria, which is in the Middle East, it's in Japan, it's in Africa, East Asia, and in Tibet, in the Himalayan region. It's spread all around. So from a geneticist standpoint, you got, okay, where's the point of origin? Mm-hmm. Some geneticists say Africa. Some geneticists say Asia, because like, wait, they start in Asia. It's easier to explain that the split started in Asia because you can see around the Himalayan region is where the D markers mainly have their distribution. And the E markers on the other side of Himalaya. So they believe that that's the split point. That's the location that they split at.
So what you're saying is, in other words, this is also great evidence for the fact that Yap is not isolated to West Africa.
Facts. Yeah. These people are highly migratory. They did not stay in one. If they would have stayed in one place, all the information that Sean shared with y'all, all of the natural disasters that was going on, there would be no humans. We would all die out, because when a flood happened, when glaciation happened, when temperature changes, when climate changes, when the megafauna and the animals of the land and stuff of nature causes people to move and uproot. If you stay in one place, you die.
I know you. Oh, I was go ahead.
No, go ahead, Moore. You got it.
No, I was asking. I was like, I know you're not meaning to suggest that Yap migrated into West Africa.
Most definitely, Yap migrated into West Africa. I don't think there's one geneticist alive that won't say that Yap started in West Africa.
You mean it's not attached to West Africa? It's not indigenous to West Africa?
Not at all.
Wow.
Not at all. Yap is not. I don't think, maybe someone can show me the evidence pointing towards that. I've never seen it. So
breaking hearts.
So we waiting on
I'm
you,
ready.
Sean. All right, go ahead, brother.
All right. So we have another population that would give us the modern phenotype of the Japanese today. So we're going to read a little bit of this paper. It's getting late, so I'm not going to keep y'all too much longer. Plus, I got to get up in like 3 hours. So I'm going to try to run through this real quick. The ancient genomics reveals tripartite origins of Japanese populations. Abstract. Prehistoric Japan underwent a rapid transformation in the past 3,000 years. First, from foragers to wet rice farming, and then to a state formation. A long-standing hypothesis posits that mainland Japanese populations derive dual ancestry from indigenous Jomon hunter-gatherer fishers and succeeding Yayoi farmers. However, the genomic impact of agriculture migration and subsequent socio-cultural changes remains unclear. We report 12 ancient Japanese genomes from pre- and post-farming periods. Our analysis finds that the Jomon maintained a small effective population size of 1,000 over several millennia, with a deep divergence from continental populations dated to 20,000 to 15,000 years ago, a period that saw the insularization of Japan through rising sea levels. Rice cultivation was introduced by people with Northeast Asian ancestry. Unexpectedly, we identify a later influx of East Asian ancestry during the Imperial Kofun period. These three ancestral components continue to characterize present-day populations, supporting a tripartite model of Japanese genomic origins. Actually, I want to go. All right, you know what? So these Kofun, all right, so I'm going to just go to this graph here. I'm going to try to walk through this graph with y'all real quick. So the Kofun is something that they just recently found that this particular population who pretty much created a governmental system, an imperial system that lasted beyond the Yayoi period up until about 700 CE. And today, a lot of the culture is based on these particular people. So we have the Jomon, the Yayoi, and the Kofun. We have the newly sequenced, which represents the dot, and then the previously published by the triangle. So here we have a map of the Japanese archipelago, and you see here it's pretty small. I don't know if you guys can see it. if you could follow my cursor, the Yayoi, right? So they would have been off of the Korean peninsula, and they would have landed here. All of these that you see here are all specimens, right? So the ones that are that have triangles, they were previously published, and the ones with circles are pretty much new. So you have the graph. You see it says age thousands of years before present. So going back at least 9,000 years, they have a sample or a specimen. This is newly published, or newly published according to this particular article, um, which dates. Excuse me, let me get the date. Which was dated. Where's the date? Where's the date? 2021, September 2021. All right. So this is the oldest Jomon because it's in red. You see the Jomon in red. This is the oldest Jomon sample that they have, recently published. And then you see we go down to about 7,000. They have all of these from 7,000 to around 5,500 BCE. They have 1, 2, 3, 4, 5 more samples that they sequence. These are all new. They get to the late, and then there's a few that they have newly sequenced, and then we have 2 that are already published. So it's showing the Jomon established, these Yap carriers established a stronghold in the archipelago for anybody else. Then we have the Yayoi around, it says 3000 BCE, but those papers put them around 500 to 300 BCE, entering through the Korean peninsula. And you see these are already published, the squares yellow, and then this Jomon is already published. And then after them, we have around the Kofun are said to come around the same time as the Yayoi, but after. So we're saying 300 to 100 BC, and we have 2 new samples, which are these 2 blue here. Results. Do I want to go to the results, or I want to go to touch on this a little bit too. Okay. So they're showing the clustering of these people. So the red again will be the Jomon, the yellow would be the Yayoi, and the blue would be the Kofun. And you see how they cluster close together, according to the ancient sequencing of the genome. And once again, we have ancient to present day Japanese. You see that the Jomon pretty much controlled the archipelago until the Yayoi came in. The Yayoi is in yellow. Then we have the Kofun, and then we have present day Japan, which shows pretty much the Jomon DNA that was pretty much pushed out. And so you see that there at the bottom. Deep divergence of Jomon lineage and geographic isolation. No, I don't want that. I want, where is it? Okay, I pretty much don't have to go through the admixture because it's pretty much, we went through that already with the genetic ancestry during the Kofun period. Sorry, y'all, I'm just trying to rush through this real quick because it's getting late. Discussion, genome transition, empower with the cultural transition, and pre. Again, that's extra. You guys could go through this paper when you're ready. Materials and methods, DNA extraction. Where is the conclusion? Y-chromosome, haplogroup, genotype, admixture, demographic modeling. Where's the acknowledgement? No. Data and admixture dates. Sequence data processing, extraction materials. Okay, you know what? Let's go to the last part, which is the Kofun. I want to just close out with this. So hold on, guys. For a second, let me grab this last source.
All right, my brother about to get ready to wrap it up with the sources, man. He gave you guys a lot. You can always rewatch the video, take notes, grab the sources, read for yourselves. For those that are interested in, in the Yap ancestry. Again, the Yap ancestry is bigger than just, West Central Africa. It's all of Africa because there's a lot of people there. So yeah, best time we did touch on that. I brought it out, D0, and also the D0 in Nigeria, which has been called D2, and also the Saudi Arabian samples as well as the Syrian samples. So I touched on that briefly.
Yeah, D was out there moving.
All right. Y'all ready for me?
You got it.
Yep.
All right. So we're going to end off with the Kofun, which was the last population. The Kofun are known for a few things, so we're going to deal with them real quick, and then we're going to close out the show. All right. So the Kofun period is an area in the history of Japan from about 300 to 538 AD, the date of the introduction of Buddhism. Following the Yayoi period, the Kofun and the subsequent Asuka periods are sometimes collectively called the Yamamoto period. This period is the earliest era of recorded history in Japan, but studies depend heavily on archaeology since the chronology of historical sources tends to be distorted. The word kofun is Japanese for the type of burial mound dated from the era. And you can see right here in this tradition, it's basically a burial mound or a tomb in historical Japan. Okay. It is the period of cultural import continuing from the Yayoi period. The Kofun period is characterized by influence from China and the Korean Peninsula. Archaeologists consider it a shared culture across the southern Korean peninsula, Kyushu and Honshu. On the other hand, the most prosperous keyhole-shaped burial mounds in Japan during this period were approximately 5,000 in Japan from the middle of the 3rd century in the Yayoi period to the 7th century in the Asuka period. And many of them had huge tombs. But in the southern Korean peninsula, there were only 13 from the 5th century to the 6th century, and the tombs were small. Wall decorations of Japanese style armor, which are characteristic of older Japanese burial mounds, were excavated with 5,000 century from 5th century burial mounds in the southern Korean peninsula. This shows that Japan and the southern Korean peninsula influenced each other. According to the Nihon Shoki, Buddhism and the Chinese writing system were introduced near the end of the period from Baekje. The Kofun period recorded Japanese earliest political centralization when the Yamamoto clan rose to power in southwestern Japan, established the imperial house, and helped control trade routes across the region. All right, that's it. We're gonna close out there. All right, so all the sources were presented. You guys could go through it. It's getting late. I'm stumbling on my words. I'm tired. I got to get up in like 2 hours. So with that, I'm going to end the presentation. And later on, we'll probably touch on the Adam and Eve. And then from there, myself and Mo are going to work our way into the other populations, Haplogroup C, going into the Beringian culture and making their way into the Americas.
You mind if I share a couple pictures right quick? I know you got to pass out, so I'll make it real fast.
No. Go ahead. You can take over. You can take the wheel.
Yeah. So while OG was giving this presentation, appreciate the presentation, a lot of great information and whatnot. a couple pictures jumped in my head, and there was some stuff he was saying. He was talking about some dates and some stuff. I was like, you know what? Let me look into something right quick. And so, and there was stuff that Yeshua was talking about that also gave me the same concept. So, real quick, I want to share my screen, put this on a slideshow, run through a couple of pictures right quick. So, you can look up Haplogroup D or whatnot and see the distribution thereof or whatnot. Something I want to touch on is the phenotype differences and something intriguing about a couple of names or whatnot. So right here is a brother who was from the Japanese Islands or whatnot. Again, with that Haplogroup D, like the OG was talking about. And if we go further, here's a brother from Tibet. Also from a group of people who carry Haplogroup D and whatnot. You can follow distribution and whatnot. You can see this is just examples. This isn't everybody the distribution. This is examples of whatnot. This is a brother from the Miao people of China. So we've got Japanese Islanders, Tibetan people. Now we got a brother in China. Here's another person from China, from the Yi people. A lot of people don't know there's multiple different multiple different ethnic groups within the Chinese people and whatnot. And so there's a few different ones that carry D, and the Yi are one of them. This is an Ainu brother from Japan or whatnot. Another a group of D carriers or whatnot. And you can see the phenotype difference between all these people. So this is why we keep talking about the concept of phenotype being fluid or whatnot. In low numbers, you can see people in Thailand. This is a Thai brother. They carry Haplogroup D. And if you keep going further, like they were talking about the Mon Khmer cultures and whatnot, these are descendants thereof and whatnot. This is a Vietnamese brother. Again, they in low percentages carry Haplogroup D. But what's interesting is, this is a Korean brother. They again also carry Haplogroup D in very, very, very low percentages and whatnot. But something that hit me is I don't know if you said Yamata Koku or something. You said Koku somewhere in your presentation, OG. There's many places in Japan at different time periods that have Koku in the name, and it's something just struck a bell for me. I wanted to point out to people. So Yeshua was talking about like he one of the potential original names for Japan or whatnot. The oldest name that we have for Japan, well, the oldest name is going to be like a Jomon name that we don't have, right? But the oldest name that we have on record is a name called Wa. And another name that goes along with it is Wakoku. And so what's interesting about this name is Wa has a meaning. It has multiple meanings, but one of the meanings that it has is like a dwarf people or a minuscule people or a pygmy type person or whatnot, right? And so Koku is an interesting name because if Sean, I, or Yeshua was to go to Japan, they call us Kokujin. That's the name for a black person, Kokujin. And so a potential understanding of the name Wakoku is like black pygmy or a black dwarf of something of that nature, whatnot, right? And what's interesting is so like the Japanese Islanders or whatnot, to this day they're called negritos, which is the exact same meaning in Spanish. It's a little black person in Spanish. And so just food for thought. I thought it was interesting that this concept of little black person has been floating around from like the Chinese, the Korean, the Japanese, and also to the Spanish and Portuguese when they got into the area and whatnot. And so it's just an interesting concept to understand that Haplogroup D has been in the area for a long time, and it's looked different throughout the ages or whatnot. But shout out to OG because that was a fantastic presentation.
Yeah, so let me share something real quick again, what you were saying about, where is it? Let me find it. I'm sorry, I just opened the screen back up. Go ahead, Yeshua, if you want to say something.
Yeah, excellent presentation. Speak on what Moore was bringing out earlier. That's the same thing Dan Shu was pointing towards, that there were a group of Black Africans that existed in the past, and one split off and developed tall Black Africans, just in simplistic, way of putting this, and the other a variation of short Black Africans. To paraphrase what the geneticist Dan Shu, so great visual aid to that as well. And food for thought there. I did not know about the Wakoku and what that potentially could mean. Maybe that is its derivation. That's very interesting.
Yeah, I'm sharing. You can see.
Yep.
You go.
Yeah, so I'm going back because you was showing some phenotypical pictures of certain people. So the Han and different Japanese people, where we find D1B is pretty much along. If you see here, D1B, you have it amongst the Japanese at 39%, amongst the Ainu at 85%. You have it amongst the North Japanese at 61%, East Japanese at 39%, West Japan 27%, Ryukyuans 45.5%, Koreans 2.5%. So you have, the Han Chinese, it's a little negligible, but you still find them amongst the majority of the Southeast Asian or East Asia populations. I just want to show that real quick. And this is from the origins of the Japanese people, if anybody want to go look for it.
All right. Great presentation, Sean. Y'all know the slogan? Yeah.
Yeah.
Yeah.